Today it's about a 3D printed housing for electronics with clever features. Magnets are holding it together instead of screws. Our new electronics casing design is comprising some clever features that you can use for other housings as well. The prototype of our slot car lap counter is integrated into our racetrack, and we enjoy the features which we specified and implemented ourselves. We documented its development in earlier videos. It's no hurdle for DIY electronics fans, but I need to admit that the assembly was a bit complex. Today I have good news for everyone. It will become much easier to build that lap counter. Today we are designing a suitable casing for the printed circuit board that we recently introduced. Like the electronics printed board, the housing has become more compact, and we are making sure that the assembly is becoming much easier. First of all, we have the inner part of the housing that carries the electronics boards. Inside we find some bases with small knobs that fit exactly into the mounting holes of the printed circuit boards. You simply put the electronics on it and then secure the board with a little paint. I'm recycling my wife's nail polish, which is no longer in use because the color is out of fashion. These are the sockets for the main board with the LEDs and the ESP32 board. The relay board goes in here on the side. The bases on the other side are intended to mount a small universal printed board. I'm not using them yet. You can use them in case you want to add any further electronics to it. The holes for the 5mm LEDs each have a diameter of 5.3 mm. This gives us some room to compensate for the small deviations we are likely to get when soldering in the LEDs. The brackets for the two infrared sensors are adjustable so that we can adapt the sensors to different track widths. The two crossbars are giving the inner part stability, and we have some holes for cable ties to fix our cables. The inner part is over 200 mm wide, and that might be a problem for smaller 3D printers when it exceeds the maximum printing span. Of course, that would be a shame. That's why I thought of a little trick and cut the corners so that a 195mm x 195mm printing area is enough to print the part. I clipped the corners in FreeCAD using a Boolean operation between the green body and the original inner part. When assembled, you won't see the clipped corners because they are covered by the front and back parts of the housing. Now we see the front parts of the casing. And there is an interesting detail here. Small neodymium magnets are simply glued into these two holes and will later hold the housing together. The magnets are 20mm in diameter times 2mm. The three other bases we can use as a strain relief for the cables, which we will lead into the housing through the hole at the bottom. Optionally, you can attach the casing to the base plate of your model racetrack with long screws that are going through the bases at the bottom. The only screws that are really needed are two M3 screws that hold the front parts together up here. Now the two back parts are added. By the way, the parts are all different. It is a tongue and groove construction so that the shapes interlock and form a stable shape when nested together. Let's take a closer look. We need to consider certain tolerances when 3D printing, which is why you see the small gaps in the construction here. In this way, we make sure that we can really put the pieces together. At the end, the starting light covers are added. I need to mention that for these little parts you have to get the best accuracy out of your printer in order to get the detailed structures. And oh yeah, I almost forgot to mention this. We have 3D printed letters that you can glue on. I tried to attach the inscription according to the curved housing. It wasn't that easy with the cursive letters. You really need to take your time for this. This is what the finished new version looks like. It's more compact compared to the prototype. The look comes close to a racing tire. Cool, isn't it? But the older prototype design is already looking damn good too. I can't decide which design I like best. In the end, it's a matter of taste. Which design do you like more? Tell me in the comments. On your own model racetrack, you will probably have your own ideas to pimp the lap counter. The surface could be improved by sanding and painting. There are many suggestions on YouTube about this. The front and back of the casing is flat, so you can attach ads, stickers, writing, etc. here. And then I have a cool tip for you. If you have assigned your lap counter a fixed local IP address in your Wi-Fi network, then you simply take a QR encoder and generate a QR code for this IP address. You just stick it on the lap counter and then you don't need to remember the IP address. Here is an example of what it looks like. In my case, I use the QR code for Electronics Unmasked on YouTube. You just take your smartphone's or tablet's camera and off we go. I like both designs from an aesthetic point of view. With the version 2.0 we can build the project much easier and faster now. Of course, the printed circuit we designed is also helping a lot on that. Our Arduino code version 3.3.2 is running stable. However, we will improve the code further and we will add new interesting features. The principle with the neodymium magnets works great. It actually makes opening and closing very convenient. I will certainly use this trick for other projects too. In the coming video we will discuss the assembly. Now stay tuned and don't forget to support the channel. See you soon in the coming episodes.